Hello everyone, welcome back to Brainbox Notion. I'm Yusuf Musa Oba. So in today's video, I'll be showing you how to perform a complete MEP takeoff using PlanSwift. So whether you are working on electrical, plumbing, or HVAC, this tutorial will help you master how to measure and also organize your MEP quantities like a pro. So grab your drawings and open your PlanSwift and let's get started with mastering MEP. And also do not forget to like, subscribe, and turn on the notification for more professional tutorials coming your way. So here we have all our drawings being imported. So if you are new with PlanSwift, if you don't know how to import your drawings, you can check our video on introduction to PlanSwift. So here we have our drawings ready. We have the HVAC drawing. We also have the plumbing drawings. We also have the electrical drawing. Then we have some informations which you need to know before we start our takeoff. So the key to mastering any quantity takeoff is understanding the construction technology. So if you don't know the construction technology, you cannot measure what you don't know. So the first thing to do is to understand the construction technology so that everything will be easy and it will move fine and better for you. So before we start, let's look at some of the electrical fittings and also how they are being measured and what is the construction technology behind everything, so that when we start our takeoff, everything will make sense better for you. So here we have a 3-room electrical wiring, full house wiring diagram. So you can see we have the meter here, we have the MCB, then we have the circuit breakers, then we have the switches, we have the socket, we also have the switches, we also have the socket here. So you can see in here, everything starts from here, which is the meter. So the electric has to come from the pole or whichever system you are using to the meter before it will not be distributed to the building. So how is this light being distributed? So this is what we are going to look at now. So before you start any takeoff, the first thing to do is to understand the construction technology. So here we have a diagram on how these things are being distributed. So you can see we have here, this is the pole, from the pole to the meter, from the meter to the MCB, then from the MCB to the circuit breakers, then to the rooms, and so on. Then here you can see we have another diagram here, which it shows here we have the meter, then we have the MCB, then we have the circuit breakers, we have the sockets, we have the lamps, we have the fan, and we have the fridge. So how is this thing being done? So when you understand the construction technology, when we start the measurement, it's going to be easy and better for you. So here you can see this is our meter, and the light came in from the meter to the MCB and then to the circuit breaker. This is the first circuit breaker. You can see this is for speed regulator. This circuit breaker is for the fan. Then this is for switch 1. This circuit breaker is for this. Then this is for switch 2. And then this is for socket. So you can see all these things depending on the distribution. So you need to put a circuit breaker for each one of them depending on the distribution. So for the lightnings, you can have one circuit breaker for the lightning. For the fans, which is kind of heavier, you can have another circuit breaker for it. And also for the sockets, you can have another circuit breaker for the socket. So this is how it is done. We have this first red cable from the circuit breaker. It goes to this circuit breaker here, and this move from this point to the socket, from the circuit breaker to the switch, then from the switch it moves to the lamp. So the same with the second one. From here we have the circuit breaker moves to the switch and then move to the lamp. Then we have the first one here, which is also from the circuit breaker to the regulator and then to the fan. Then we have the fourth one, from the circuit breaker to the socket and then to the fridge. Then we have the second cable, you can see, which also apply to all of them. So from here, from the MCB, it moves to the lamp, to the lamp 2, to the fan, and also to the fridge, which is to the socket. So from the socket, you connect and it's connect to the switch too. Then we have the earthing 2, which goes to the fan and also to the fridge. So this is how the connection is done. So let's look at another diagram again to have a more clearer picture. So in this diagram, you can see we have a distribution box, we have a ceiling light, we have a light, we have fan, we have outdoor, we have doorbell, we have light bar. So you can see how this is being distributed. So one key thing you need to understand about MEP, especially electrical, when you are working with electrical, at each room, after you connect all your fittings and lightnings, you need to return back to the distribution board. So you can see here, this is the corridor here. You can see we have some lightnings here, and all the lightnings are being connected back to the distribution board. And this is the entrance here, or maybe the living room. You can see being connected, and it also return back to the distribution board. And this is the second room. We have all the lightnings, the fans and everything, and it's all returned back to the distribution board. And here we also have the outdoor, and here we also have the doorbell, and they all return back to the distribution board. So one thing you need to keep in mind is when you are working with electrical, whatever connection on each room, you have to link it back to the distribution board. So that is another thing to keep note. Then we have another example here, which shows forum wiring. We have from the pole to the meter, to the MCB, to the circuit breakers, then to the rooms. You can see how it is being distributed to the rooms. Then we have the fittings that we need to look at that has to do with electrical. Here we have a four-way junction box. So this will make sense better when we start our takeoff. Then we have a three-way junction box. We have a two-way junction box. We have one-way junction box. We have PVC conduit pipes. We have Y-type junction box, and so on. So I'll just give you a few minutes to just look at this, or you can easily browse it. It is in the internet, and you can get the picture and then look at it better. So we have the flexible copper wire, we have the MCB, we have the RCCB, we have the MCB cover, we have the LED bulbs, we have a lot of things here. We have the modular gang box, flexible PVC, we have pipe saddle, we have the coupling, we have the end cap, we have the junction box, we have the ceiling rows, we have the bent 45 degree, we have the bent 90 degree, we have 5-way cross elbow, and so on. So we have a lot of them here. When we start our measurement, we have elbow 90 degree, we have elbow 45 degree also. So when we start our measurement, this is all going to make sense better. So let's look at another diagram. So you can see here the way this is being distributed. You can see here the way it is being distributed. So this is another three-room electrical wiring, full house wiring. So another thing you need to keep note of this is all the rooms, you can see all the connections for this room, they all return back to the circuit breaker and then to the MCB and then to the meter. So for this room also, after connecting everything, it returns back to the circuit breaker for that room, moves to the MCB and also to the distribution. Then the second room also, after connecting everything, it's all returned back to the circuit breaker and then to the MCB and also to the distribution and also to the meter. So the last example here is also the fittings, which you can also browse and then check it. So let's look at our electrical plan and then see how this is being done. So we need to rotate this page. I'll rotate right, no, rotate left. Okay, so here is a lightning point. This is the ground floor. So what you need to keep in mind is, you can see here, we have our cable. You can see the way the cable is being designed. You can see the way it is being designed. So mostly what people usually do is, they will just use your linear tool. Here, pick your linear tool. I have to scale, I will do that later. So you just pick your linear tool and then trace this cable. So it's not be considered as your measurement. Actually, it is wrong in some ways, because you don't usually leave your cables like this. Usually, they are all conduits, depending on the type of, if you're using piping, if you're using trunking, depending on the type of piping you want to use. So it is kind of wrong, because we don't usually lay our cables like this, to go like this, to bend like this, like this, like this. So what we see here in the picture, in this picture here, you can see, so all these cables are being passed through the pipe, the PVC pipe. They are all being passed through the PVC pipe. So what you need to put in mind is, they're all being passed through the PVC pipe. So if you have a drawing whereby it shows you the arrangement of the pipe, which is how the pipe are being arranged or how they are being laid and so on, that will be better. But for drawings, mostly we do usually have drawings like this. Like for example, you can see this is a wire here for this toilet. You can see the way it's bent. So this is not going to be installed like this. So this is not going to be installed like this. So measuring MEP just by clicking on the lines, measure cable like this, is kind of wrong. So let's check another example here. Under MEP, this is HVAC. So you can see another example here. So look at how the pipes are being, look at how the cable are being laid from here to here, from here to here, from here to here, from here to here. So definitely you know that we are not going to fix the lighting in this, with this arrangement. We are going to have a proper arrangement to fix the lighting. We're not going to fix it like this. We need a proper arrangement for this. So, and again, when you look at this, you can see where is our distribution board. I think this is our distribution board here. You can see we have our distribution board here. So when you look at the connection here, you can see from this place to this place, there's no link to the distribution board. For this room entirely, it connects to this room, connect 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 to this room, connect. Then we have just a link here to the distribution board. We have another one here, link to the distribution board. You can see it is link to this, link to this, link to this, and then to the distribution board. So when you look at this, you know that, okay, we are not going to arrange, it is not proper to arrange our lightning the way it is like this, from here, 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 and then you move it to the distribution board. So you need to have a proper way of arrangement. So when we look at another design, so you can see this is a socket plan for the first floor. You can see the way it is arranged. This is the socket plan. From this point, it goes like this, it goes like this, it goes like this, and then to the distribution board. From here, it goes like this, goes like this, and then it moves to the distribution board. So you can see the way this is arranged. So this is kind of better. So if you have a plan like this, you can work with something like this for your socket piping. So the moment you pipe everything, you are going to use this now to lay your wires, and also for the lightning, you can also have a different pattern or way of arranging your lightning. So this is for the socket. And also for the lightning, we need to have a proper way or a proper channel or a proper area. Let's say, for example, everything that has to do with this room, we have pipes coming from this room, and we have another pipes coming from this room. So we can decide to move our pipe either this way, to come this way, and then move this way. Or we can decide to move our pipe to go this way and then move this way to the distribution in a very straight and arranged manner. So you can't just scatter your pipes all around the house because you want to do your piping. So you need to connect them, couple them in one place, arrange them straight. If you have 5 to 10 pipes, you arrange them, move them on a straight line, straight to your distribution board. So that is the ideal and the practical way to arrange it, not the way we usually used to see in our lighting. You can see here the way it is scattered all around. So this is not the proper way. So to measure it, you need to arrange it properly. So enough of the talking. So let's move to the main takeoff. So if you are equipped with the template, the MEP template, we can go to BrainBox Expert System, go to MEP, you see mechanical, electrical, and plumbing. So if you are also not equipped with the template, you can check the link in the video description to get the template. So here, let's start with electrical. So you can see under the template, we have the pipes. Under the pipe, we have the deep junction box, which is this. This is a deep junction box. We have the stainless steel bearing. We have the junction box. We have the coupling. We have the 90-degree elbow. We have the fan box, and so on. Then we have the wiring. 1.5. We have 2.5. We have 4.0. We have 6. So when you click on this, sorry, let me go back to a fresh page. So let me scale this 2.8. Click OK. So when I double click on this wire, so you can see this is the information I get. I have the ability to add my drop/rise. Then I will now specify the number of drop/rise. Then I will now specify the allowance for connection. So you need to allow allowance for connection, depending on the percentage you want to use. So also, when you look at the 2.5 wiring, we have the same thing, the 4 point and the 6 mm. So even though we have just this, if you have another type of wire, you can easily just specify it and then edit the name. Then also for the pipe, if you want to specify the size, you can double click and then edit the pipe and the size here. So what we need to put in place here is, when we go back to this MEP drawing here, so you can see this is the connection for this. This is the switch. This is the connection, and this is the switch. And also this is another connection. This is the switch. This is the switch. And then, so that is that. So for this, let's say, for example, here we have the pipe. So how do we measure this electrical pipe? The circuit plan. You can see the way it is being distributed. So to measure this, you can just go to the template under MEP. You click. So I need to specify a scale. So I will just pick 0.9, which is a door. Click OK. And then locate any 0.9 door. So I have one here. So you can see here, it shows me to specify my vertical pipes and number of vertical pipes. So don't worry, I can easily click OK and then start my measurement. So I'm going to start with this one here. So, you know, this is on the wall. So I'm going to start here, 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 and then here to the distribution board. So I'm going to stop this. So I can easily continue. You can see we have 14.3 meters that runs from this, and this. And also, mind you, if you, and also mind you, depending on the connection you want to use, if you want to use a bigger cable and then connect more than one wire, you can do that. But if you want to connect a single wire, which is more better and easy to maintain, connect each wire with its own pipe. So you can just click on continue or add this to this, and then this will go to this point, this point, this point, this point, this point, and then this point. So mind you, you can see the way this is connected from this point to 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 this point. Wait, and this one is connected from this point to this point to this point to this point and this point. So why do they have a separate? So why do they have a separate? Why are they connected separately? Why is this and this and this and this joined together, and this is not joined together with them? Why? Because here you can see it is not the same type with the others. So this is going to pick up more load than this one. So they are going to use a separate cable for this and a separate type of cable for this, or a separate MCB circuit breaker for this and a separate circuit breaker for this, depending on the load. So here we need to connect this to the wall. And then that is how you are going to measure for the whole area. So so this is for the pipe. We have 32.8 meters. This is for the pipe. So mind you, here, this pipe is not going to be connected to the floor. It has a rise. So what is the rise from our floor to where we want to connect this socket? So depending on how high you want to connect your socket, if you want to go 0.9, 0.6, 0.5, and so on, depending on how high you want to connect your pipe. So for this tutorial, I'm going to use 0.6 as my drop or rise. So basically, this is a rise, not a drop. So I'm going to use 0.6 for my rise for this. So which point and which point do I have my rise here? So you can see I need to shift this a little bit. Yeah. So how many rise do I have for this? I have one rise here. I have another rise here. I have another rise here. I have another rise here. And then I have another rise here. But mind you, the rise at this point and the one at this point is not the same. You can see the one at this point and the one at this point is not the same, because this goes to the circuit breaker or to the distribution board, while this is for the connection. So here I'm going to use 0.6. So 0.6, 1, 2, 3, 4 in 4 places. So I'm going to click. Our rise is 0.6 in 4 places, and then click OK. So you can see after adding our rise, we have 35.4 meters. So what about this area here? What is the rise for this area? So this area, we have a rise of, let's say, 3 meters, depending on the height of your building. So I'm taking this up to 3 meters high. So 3 meters by 2, which is going to give us 6 meter. So you can see 6 meter. So this is going to be whatever we have here plus 6 meter. So when I am adding up my BOQ, I'm going to take note of this, whatever length I have, plus 6 meter. So this is for this. So basically, this is how you are going to apply the same method to all the rooms here. So I'm not going to measure all. I will allow you to measure the rest. So we have the drawing in the video description and also the template for you to check and then grab and then perform your takeoff yourself. So this is for the socket. So let's go to the wiring. This is also a socket plan. So here you can see, depending on the type of drawing you receive and also how this drawing is being set. So you can see, let me show you something about this drawing. So this is a set. Ceiling installation set, ceiling installation set, ceiling installation set, ceiling installation set. So this is given as a set. So you need to be careful of the information you are given. So if this is a set, you need a shop drawing to see complete detail on how this is being distributed and the type of lighting being used. So we have another MEP electrical drawing here. You can see here. So this, we are also going to measure the pipe. Then the pipe we can now use the measurement for the pipe to also allocate the wiring and then give allowance. So here, I'm also going to do the same thing. So I need to scale. I will pick 0.9. So whenever you are working with MIE drawing, which usually don't have dimensions for you to scale, so always use the door or window to scale. So 0.9. So I think this is a 0.9 door. So we have our vertical drop / rise and we have the number of rise. So I'll click OK. And then the arrangement is, you can see this one for this, another one for this, one for this, and another one for this. So I'm going to measure this, 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 this. Then I will not take it to this point, or I can go this way and then go this way. So the reason why I'm breaking the line at each point here, I will show you why. And also here you can see we have which we need to consider here. So here you can see from this point, we are going to have a joint. 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 So also take note of all these things. You can see we have some pre-made, not all, so you can easily click and edit. So you don't need to use this. For this pipe, let's say for example here, we've measured this and we have elbows, which we need to consider. So you can see under this, I can just click on the 90-degree elbow on the areas which I have my elbow. So basically for this, you can see we have 11 elbows. 1, 2, 3, 4, 5, 6. 11 elbows for this. So this is how you also capture the elbows, the joints, the junction box, and so on. So let's move back to the electrical, the lightning again. So here I've measured this to this point. So I can also measure this. I'll click on this, click on this, click on this, click on this. Then I will now move up to this point, or move from this point, and then this point. So this is how I decide to move this way. So you can also decide to move your own way, or we can easily, let me delete this, and then continue. So I can move this way, and move this way, and then move this way. For this. So depending on how you want to make your arrangement, so you can see here, we have some of this junction box here. So here we have one-way junction box. So we need one-way junction box here. Then we need, we need two-way junction box at this point. So we have one-way junction box, two-way junction box, two-way junction box, two-way junction box, and our elbow here. One-way junction box, two-way junction box, two-way junction box, two-way junction box, elbow, elbow, and then this. So that is how you count the fittings too also. So you can easily do that by have this measured. So I can, this is a bearer, I can double click on this. I'll call this one way junction box. Click OK. This and this. Stop. And we have another junction box. So I'll call this two-way junction box. Click OK. I have one here. So you can see the reason why I used to break the line on each fitting. So it gives you the ability to just pick a point to put in your fitting and then click OK. So this is how you measure the fittings for the junction boxes, also for other lightning fittings. So here we have the pipe, we have the fittings, which are the junction boxes, the elbows, and so on. So this is how you measure them. So what about the lighting and the fittings? So this is basically easy. They are basically count. So you can see here under the distribution board for our template, we have different, we have the MCB, we have the MCCB, we have the RCB, we have the ELCB, we have the RCBO, we have the MPCB, we have the isolator. So we have everything listed here. So anyone specified within your drawing, you can easily pick one of them here and then click. So depending on the one described, you can easily pick them. So also when you double click on this, you can see we have information on the use. So it is usually mostly used for overload and short circuit. This is also for overload and short circuit. Then the RCB, which is the residual current circuit breaker. is used for so you can see here, it's disconnect the circuit whenever there is a leakage or current flow through human body, or the current is not balanced between the phase conductor. So you can see this is for the RCCB. The use is it's disconnect the circuit whenever there is a leakage of current flow through human body, or the current is not balanced between the phase conductor. So this is for the RCCB. So also for the others, the ELCB, you can see we have the use and so on. So you decide, this will guide you and give you more insight on what to do with all of this. So you can also double click and then check the use here. So also for the others, then we have the lightning fittings, which we have some here. You can easily create this. Also count. We have the socket switches. We have the ventilation and air conditioning, the TV outlets, the cooler units, the smoke detectors, and so on. So you can easily just pick this from the template here and measure, or you can easily add yours. In here, you can duplicate any of this to add more. You can give this Opera, give this MCB. So you can easily add and delete from this point for each of the fittings and the junction box. So you can easily add and delete even the wires. You can easily add and delete. You can see for each wire we have the switches. So the moment after measuring the wires, when you want to measure the switches, you can easily pick for each of the wire how many switches do you have. You can easily edit the name, put the name of that switch, one way, two way, two gang, three gang, whichever one you want to use. You can edit the switch name here and then put in what you want to put in and then continue your takeoff. So basically, electrical, we've covered most of the things. The rest are just counting, which you can utilize the auto count feature within PlanSwift to do most of this counting. Yeah, you can utilize the auto count feature to do the counting. And also for the plumbing and mechanical, in our next video, we are going to read that. So do not forget to like, subscribe, and hit the notification bell so that you don't miss out on the next video. Thank you for watching. See you on the next one.